smoke control. Okay. I thought I have the slide already. Apparently not. You hold on for a while. Let me check. Smoke control. I should have it. Okay, this one I got now. Okay, thank God. Okay, I'm going to, I have already recorded. Okay, I'm already recorded. Then I go to share. Sound is there. So now we are on smoke control system. Now smoke control, of course, you all know, we all know it's very vital, So we all know that in a fire, it is the smoke that de decapacitate the occupants, not so much as the direct threat from the fire. Okay, so smoke can hurt us far away from the place of fire origin, right? So I have turned on the recording already. So we will be talking about the importance of smoke control systems, methods of smoke control, where are they used? Okay, where are they used? Where are they used is talking about a provision. Okay, provision. So same thing, importance, methods, and types and locations of smoke control system. So what is smoke? Very difficult to define, right? So they can only tell us that smoke is airborne solid made up of many kinds of substances, liquid particulates, okay, because the material is undergoing chemical pyrolysis. I hope you know what's meaning of pyrolysis. It's thermal decomposition. That means when you burn a solid, the solid won't burn immediately. It's not like flammable liquids which will vaporize. All right. You first have to dismantle the bonds between the molecules. So solids are very large molecules. We call them macromolecules. So you have to thermally take the heat and heat up the bonds so that the bonds are dismantled. Then they become smaller molecules. Then they evaporate. Then you can burn them. This process is called pyrolysis. Okay. So during this process of pyrolysis, there'll be a lot of airborne solids, liquid particles, and so on. Okay, products of incomplete combustion, meaning CO. Okay, and a lot of hot and humid stuff there, dirty, corrosive, and you will impair our visibilities. Okay, and we all know that all these will affect our respiratory system, breathing apparatus, and also toxic as well. All right. So most air deaths are caused by inhalation. Inhalation is breathing in of combustion products and smoke, not direct contact with the flame. Okay. Okay. So these are the things that the civil defense like to highlight. They say people die or get incapacitated by smoke. Okay. Then your property affected by what? Fire. Okay. So most of the time, most are not always. Of course, property also affected by smoke. Right? So property will be burned out by the fire, affected by the smoke. But most of the time, it's the smoke that affects the people. Okay? Not direct contact with the flames. So smoke contains carbon monoxide. Carbon monoxide is due to the incomplete combustion. So carbon monoxide has a strong affinity for hemoglobin. Okay, because actually by right it should be the oxygen that carries the hemoglobin around our blood cells, our system. So if carbon monoxide has a stronger affinity, then it will form carboxy hemoglobin, and it will starve our cells oxygen, and in this way we will lose consciousness. Okay, carbon dioxide as well, toxic. This one is even more dangerous, right? Hydrogen cyanide. Okay, it can kill instantly, right? It can kill instantly. Let me give us an example. During the 1970s, a lot of hijacking, okay, hijacking. And so all these terrorists, they hijack planes and blow them out, especially the North Koreans, terrorists, they keep on uh, cyanide pills in their belongings. So if they are caught, straight away they swallow the cyanide pills. Okay, and that will give them instant death. All right, it's many times higher, more toxic than carbon dioxide. Thankfully, in the fire, not much hydrogen cyanide is evolved. Okay. Then we have hydrogen chloride, which comes from PVC. All right, it's acidic, and it will corrode. Acrolein, okay, is something like what you get when you smoke cigarettes. Nitrogen oxide, progeny, and nitrogen. Okay. Now, a oxygen will be reduced in the normal course of fire. Okay, then the occupant will have problem breathing as well. All right. Carbon monoxide highly toxic. Okay, a lot of in abundant quantities. Okay, so of all fire deaths, not directly due to burns, 85% are due to carbon monoxide. Okay, 85%. So other than toxic gases, all right, the sum of all the toxic substances will also be a so-called hazardous. In fact, now computers are so advanced, and they can calculate the effects of the sum of carbon monoxide, hydrogen cyanide, hydrogen chloride, and then sum them together, and then they can simulate, say, if this is a fire, whether the fire will be toxic, depending on what kind of materials you put in the input. Okay, so very advanced simulation. But of course, you must put in the accurate things. Right? So where are we now? Okay, smoke. Small amount of smoke may be small inconvenience, but then your visibility will be affected. All right, and building designers must consider smoke as literally. Literally means deathly. That means it can cause them. Okay. Now, smoke travel very far from the room of fire origin. Why? Because the buoyancy. Okay, buoyancy means a change in density. When fire starts, the air will rise, and because it's hot, we all know that hot air rises. So the density will be reduced, so that's why it rises. Okay, so as it rises, cold air will come in, take the place of the smoke that has been risen. Okay, so this we call this air entrainment. Okay, so you strike the ceiling, then you flow and flow and flow. Okay, right. Later on, I will describe more on this. So you spread to door openings, leakages, cracks, openings around pipes. That's why a if you have a brick wall here, and you have a pipe here, or ducting, and a brick wall here, okay, the pipe penetrating the brick wall, make sure that all these are, we call it fire stop, okay, fire stop, so the gases will not be able to go through. So this is very tricky lah, because normally in the office you don't see the ceiling, right? Right, the pipe is in the ceiling, false ceiling, above the false ceiling. So unless you have access opening, you go out and you check whether this is done properly or not. Okay, most of the time it is done during the construction period. Okay, that means that the clerk of work must be very, very diligent. Okay, once the false ceiling goes up, very difficult to check. Okay, very difficult to check. So smoke movement is due to buoyancy. Buoyancy means a density change. Okay, there's a density change. The hot gases are very low density. That's why you can float away so easily. All right. Sometimes wind can also be involved. All right. Wind can also be, but less now. We are talking more about the buoyancy effect due to the fire. Okay. And smoke may be forced to the air conditioning system. That's why during a fire, we always stop the air conditioning system, mechanical ventilation, we also stop that, okay? Now, the smoke can also go to the staircases, if you don't have a pressurization system, right? Elevators, shafts also. That's why in a fire, you're not encouraged to take the lift. Okay. By the way, the word elevator is American, British is lift. Okay. So don't take lift. Why? Because the smoke. This is a lift cage, right? The smoke can come out here. Okay. So the lift cage home to the designated floor. If it's stuck somewhere, we are in trouble already. The smoke can come here and infiltrate into your lift cage. All right. And it becomes smoke lock. The word smoke lock means filled with smoke. Okay, blocking the evacuation routes, hindering firefighting. Okay. So let's say there's a fire and smoke goes up there. Then the occupants will run away, right? Okay, occupants run away. But who comes in next? After the occupants left, who will come in?
SCDF.
Correct. The firemen will come in, right? So the firemen must be able to fight the fire before they can fight the fire, right? If the whole place is filled with smoke, they can find the fire, but it takes time. Okay, so that will be a delay. So now we talk about smoke control system. Okay, we limit the smoke control, limit the spread of smoke. Okay, limit the spread of smoke. We cannot prevent it entirely, but we can provide acceptable conditions. It means fair conditions for people to run away. Okay, so we want to maintain acceptable conditions. Later on, I'll show you what the conditions along the escape roads, and also allow firefighters to locate, control the fire, and more importantly, to search and rescue. People may be trapped and so on. So smoke also like to travel along the paths taken by the air conditioning system, right? We must stop the air conditioning system, in other words, all right? We must shut down, all right? When smoke is in the return air, okay? Return air, okay? So let's say this is the air handling unit. Air handling is aircon, fan. Maybe this is a cooling coil. Okay, there'll be a motor here. So there'll be return air here, right? Return air. So what it's trying to say is that every fan, air handling unit, we should have a smoke detector here, no? Right? So when the air coming in carries smoke and hits the detector should stop the fan. Okay? However, when there's a fire, the main alarm panel should stop all the aircon system altogether. Okay? This smoke detector here is also good for the motor. If the motor overloads and cause a fire, it will be, this smoke detector will be activated and it will stop the fan. Okay? So the smoke will try to go through shafts, any so-called not shaft that travel from downstairs upstairs because of the buoyancy, the smoke will find its way up. Okay, like lift shafts, staircase shafts, pipe shaft, duct shaft, right? It will infiltrate in quite easily. That's why all this has to be fire stop. Okay, fire stop. And these are the conditions that I was talking about, right? So three things. One is radiant heat. The ceiling height should be around 2.5, not ceiling height. The acceptable height okay, should be around 2.5 meters. And the radiation must not be more than, the temperature of the smoke must not be more than 200 degrees C, so that it will not affect the people who are running away. Visibility must be more than 10 meters. CO must be not more than 2,800 parts per million for 10 minutes. Oh, people can run away. All right. These are the conditions. All these are taken from the code of practice. All right. The civil defense. So reason why we must stop air conditioning system. Okay. Now, I didn't draw the cooling coil. This is a fan. So normally no fire. This is what will happen. It will supply cool air here, pick out the heat from the room, go to the return air, and then come back. Recycle. Same thing. All right, this one will recycle. What happens if there's a fire? Say there's a fire here and smoke is evolved. So the supply air will come in, you will take the smoke, and then go to the room. Then this fan will spread the smoke here and then go back again. Okay, so at the end of the day, the smoke will be spread everywhere to every room served by this fan. All right. The worst case is in the atrium buildings. Okay. Nowadays, we have many kind of atrium buildings, like shopping centers, okay? Atrium buildings are the most scary because if you don't stop the aircon system, the whole atrium can be filled with smoke, okay? So there are two methods of controlling smoke spread, okay? One, the first method is smoke control, containment, and exhaust. Okay, smoke containment and exhaust. Now, okay, let me explain how this works. I must have a clean slide. Okay, so let me explain how this works. Let's say if I have a long corridor, okay, and there's a fire here. Like I said earlier on, the smoke will rise because of the change in the buoyancy density, right? The smoke becomes very buoyant, it will rise, then it will go to the right, go to the left, in all directions, all right? And it will transmit heat to the walls, and the walls will radiate heat downwards, okay? And there will be entrainment, air coming in to provide more smoke. So the smoke, very hot, okay? It will keep on traveling, no? Right? Of course, the further it travels, the more nasty it can become. Why? Because it mixes with the air and then it drops down. The density becomes heavier and it drops down. Bad, right? Because it will reduce the visibility of the occupants, okay, suffocate them, and so on and so forth. So what we need to do is to put a barrier here, okay? This is called a downstand. So this downstand is actually part of the building structure, no? Most of them is done by the architects. You may not even know it because the downstand may be a piece of advertisement or something like that, okay? So, right, downstand is a barrier. So, we want to contain the smoke in its hot condition. Hot means it is still very buoyant and you stay up there. It won't come down, right? If you allow it to flow and flow and flow, it becomes cold because it mixes with the air, then you drop down. All right, that's bad news. So we stop it here, then it will come down, it will curl up again. Why? Because it's still very hot. Okay, still very hot, it will curl up. So you form a hot layer here. All right, hot upper layer. Okay, and hot upper layer you continue to radiate heat down. Don't forget that. So for somehow we need to have some fans here to remove the smoke to the exterior. Okay, when we are removing the smoke, you must supply air inside. Why? For example, if you have a box, let's say you drink the bubble tea, if you have a straw here, you drink out all the tea. What will happen at the end? This is a box. At the end, the box will collapse. Why? Because it's a vacuum. Okay. Same thing here. You must allow air to come in so that the building won't collapse. The fan will not work properly. Okay. If you have a hole here, air will come in, then the box will not collapse. You still can take the straw and drink your water. Okay. So same idea. You must have air coming in here. Okay. So that it will, of course, you may argue the air coming in will fuel, add oxygen to the fire. Yeah, you are correct. But adding oxygen to the fire is not as serious as being threatened by the smoke. Okay? Being threatened by the smoke. If the fans are not working properly, the hot layer will drop down and everyone will be threatened. Okay? So that is not so good. Okay? So in a fire, say this is a shopping center, the atrium. In a fire, all right, when the alarm bell rings, you find that the main door will open. People think that, oh, main door open is for people to run out. Yeah, that's correct. At the same time, it is for air to come in. Okay? Air to come in so that there will be fans here, so that the air that comes in at low level get heated up, then it goes to the fan. Okay? Then the fan can work properly. If you don't have the air coming in, the fan will not act properly. Okay? And in the atrium, can I ask anybody, what will be acting as the barrier? Anybody? Here we have downstairs done by the architects. Okay. What about the atrium system?
Smoke curtain.
Very good. Smoke curtain. Okay. So when the alarm bell rings, the smoke curtain will drop down. Okay. By the way, will the smoke curtain drop all the way to the ground floor? To the floor, sorry. To the ground. Will it down, down, down? Huh? Will it? You are practitioners in your building. Will the smoke curtain go all the way?
The floors above the fire floor will all drop down.
All drop down, fire floor. Let's say we have a fire in the
Above the
atrium.
fire floor.
Above the fire floor. That's what I'm trying to say is that when the smoke curtain drop, will this drop to the floor or not here? Will it go all the way or not?
Usually on the floor, we see there are markings for the smoke curtain. I mean, we
It
can
won't
see
go all the way
track.
lah.
Yeah.
It won't go all the way lah, huh? Okay. Now, just now the gentleman who say that above the fire floor, he's correct, no? Let's say if there's a fire floor, no, sorry. If there's a fire here, you cannot have the smoke curtain roll down from the fire floor because otherwise, where would the smoke go, right? So the one above the fire floor will be, smoke will be prevented from going in and smoke will be prevented from going, then it goes through, okay? However, if it's on the atrium, then all will come down, lor. But it won't go all the way, lah. That's what I'm trying to say, lah. Huh? Okay, it won't go all the way, and so people will not be. It can be very frightening, because when the smoke curtain drops, it's very noisy, lah. Huh? And especially for children, they may not know what's going on. So this you still can go in, okay. So the smoke curtain is to prevent smoke from going into the occupied areas. The other reason is for it to create a reservoir, like here, okay. Create an upper layer, hot upper layer, so that the fan will have some volume of smoke to suck up, to draw out, okay. So two reasons: prevent smoke from going into occupied areas, and also to create a reservoir, smoke reservoir, okay? So to maintain this height, that you must calculate, do some calculation, okay? The fan must be big enough to carry away the smoke that is coming out to maintain this height. Okay, if you don't have a strong fan, the layer will keep on dropping, Okay, if you keep on dropping, people will be in trouble here, especially the one in the higher floor. Okay, so normally this will be about 2.5 meters. Okay, topmost floor. They will be the first one who is affected. Okay, so this method is called containment and exhaust. It contains the smoke using barriers, and after that, it exhausts the smoke. Same thing here. We use the smoke curtain to contain the smoke, then the smoke fans to exhaust the smoke, okay? All right. Now, here I say venting. Venting means we don't use smoke fans, no? It means allow the smoke to just go out like that, no? Okay? In cold countries, I think this is fine, okay, because the cold countries, the temperature differential is quite big. But in Singapore, I think the temperature differential is not that big. All right, so the smoke may not go out so fluently. The other thing is that if you have a strong wind coming, the wind may blow the smoke back. Okay, so if you have fans here, it will still give you a positive effect. Okay, positive effect. However, for atrium buildings, definitely you need fans. Okay, they won't allow vents. When I say vents, they are natural vents. It means there may be a covering, and then there is some visible link here. When the visible link melt, this thing will be lifted up, so smoke can go through. That's the idea, lah. Okay, but going through by itself, no, okay, naturally may not happen so easily. Okay. All right, so I have talked about smoke containment and exhaust. Now, this is really to remove smoke. Okay, the next method is not about removing smoke. It's called pressurization of escape routes. It is to prevent smoke coming into the safe areas. Okay, what are safe areas? Safe areas are like your staircases. Maybe here you have a lobby here, okay? So the lift lobby, right? So together they are pressurized, okay? So we call this pressurization of staircases and also lift lobbies to prevent smoke from coming in so people can escape safely, okay? So please remember, the second method here is not about venting smoke. It's about preventing smoke from coming into the safe areas, okay? So pressurization, I think I cannot rattle on like that. I must go to the picture and then tell us what's happening. Then we go back to the text, okay? So imagine this is the smoke protected area, okay? So this can be a staircase, okay? Can be a lift lobby or a staircase. So if there's a fire here, the smoke will try to invade everywhere because it's very hot. It will try to infiltrate into the gaps between the doors, and let's say this is the lift lobby or the smoke-free lobby okay. So what we do is we have a pressurization fan, right? That's where the word pressurization comes from. It will send a strong stream of air that will blow through the gaps, okay, preventing the smoke from coming in, okay. So when will the pressurization fan start? It will start immediately when there is a smoke detector here. Smoke detector detects the smoke, means there's a fire. It will send a signal to the main alarm panel. Then the main alarm panel will send a signal to the pressurization fan. These are called the auxiliary function, secondary function to start. Okay, so almost immediately, so the the fan will blow the air through the gap, so smoke will be discouraged from coming in. But the smoke has to go somewhere, right? So it will go through the vent. Okay, all right. There are a few things you need to remember. When all the doors are shut, the pressure difference is 50 pascal. Okay, 50 pascal between the corridor and the affected area. Okay, all right, 50 pascal. Now, this 50 pascal, coincidentally leads to the force at the doorknob. The force at the doorknob is 110 newtons. You must remember this figure. They may ask you 50 pascal and 110 newton. Why is this important? You see, the air is blowing against the door. No? Okay? So if you exit 110 newton, let's say the weak people can be the elderly or children, may find it difficult to force their way in. Okay? If you exit 110 newtons. 110 newtons is a limit set by the civil defense. Of course, the civil defense borrowed it. This research was done by the British. Okay, they done a lot of research and then they come up with this figure. Okay, so your force on the doorknob should not exceed 110 Newton. Why? Because the weak, weak person, like the elderly and children, will not be able to come in. Okay, so if the pressure is too great, what will happen? There's an air relief valve here. Okay, we should open, allow air to go out so as to keep the pressure within 50 pascal. Okay, so this door must have a door closer. No? Why have a door closer? So that if there's a fire, uh, the the smoke cannot simply march in, right? Because the door is closed. So this is when the FSM must be very vigilant. Sometimes people will just wedge the door. Okay, this is not allowed. This is in fact an offense. Okay, so the for a pressurized area, okay, the door must always be closed, okay? And this is a air release valve. Very simple, no? But it works, okay? Very simple. No need to have pressure differential, that kind of thing, okay? No need. It works very well. Okay, let's go back to the text and see what it offers us. Okay, so during a fire, smoke will try to come in to the smoke-free area. At times, the door will be open. Later on, I'll talk about the door thing. So smoke will go into the protected area. Okay, so we must keep out the smoke. Okay, to keep out the smoke, we introduce fresh air pressurization. Okay, through a fan called pressurization fan to maintain the 50 Pascal. Okay, so the air will prevent the smoke from invading the safe areas. That's why we call it smoke-free lobby. Okay, smoke-protected lobby. All mean the same thing, Okay, all mean the same thing. So, in a corridor, no, not corridor. Your staircase, you see all this. This one is for air to come in. Okay, so where do you need pressurization system? Where? This, whenever you see the word provision, that means where to install by law. By law means by the civil defense. Where a building is more than 24 meters, this 24 has a meaning. And that's where the pressure, water pressure is low. Okay. The staircase is internal. Internal means not exposed to the atmosphere. For example, if this is a hotel, you may have an internal staircase. This one is internal, then you need it. I'm saying, if your staircase is around here, exposed to atmosphere, no need. All right. And the basement also very important. All right. I don't know whether I told you. There are two things firemen are wary of. Wary means fearful. When they are fighting fires in high-rise building. Why? Because that's where the pressure, water pressure is very low. Okay. Secondly, in basement. Why basement? Because in the basement, if there's a fire, okay, fire has smoke, okay, it's not exposed to the air, and smoke will all be contained here, unless it has some very strong system to exhaust the smoke. Okay, what happens if it fails? Then you'll be in problem. Okay, you will be in trouble. So basement places where it's very difficult to fight a fire. Okay, the heat from the basement, because there's no natural vein, not like up above the ground floor. See, the smoke can just go to the atmosphere. Okay, so basement requires special focus. All right, so you need a pressurization system. All right. This one is very unique. This one is talking about your condominium. Now, condominium, you see, in our HDB, our HDB, we have each HDB house as a bomb shelter, right? Okay. Now, in HDB, in condo, they may use their this staircase and shelter. Okay. So, when you use your staircase as bomb shelter, okay, then the rule says that you must have a smoke detector at the entrance there, okay, at the entrance there. All right. So see the building stairwell make as storage shelter. So it's a civil defense requirement to provide household shelter in HDB, right? But for condos, they use the stairwell. So for safety purposes, you need to have a smoke detector at the entrance there. Okay, at the entrance. Okay, good.
Sir, for all each floor, all the entrance need to have the smoke detector.
He didn't say that, no. Do you have that? You say only on the. It is to my interpretation. Let me see. It says staircase story, staircase, story, shelter. Okay, so I take it to mean that it's the entrance. Huh? There, the main entrance. Oh, it says the main entrance. So now I'm going to talk about opening doors. Okay, you see this poor elderly find it very difficult to open the door when the pressure is greater than 110 Newton. Okay, now for that to happen, I must give you a good diagram. So this is the diagram that I'm going to show you. Okay, so this diagram has many stories. I only managed to draw a few only. So this is a section view, and this one is a plan view. Okay, plan view. So everybody listening, so if there's a fire, straight away the fan will come and then it will set out a pressure of 50 Pascal. All right, this is to prevent any hint of smoke coming in. The air will be blowing already. Can you see the arrows? Okay, and there's air release valve. All right, of course, in the fire, people will be running away, isn't it? Okay, so the most critical floor is the floor here. We call it the fire floor. Okay, the fire floor. So people will be running away. Definitely they open the door, right? So when they open the door, the fan must provide an air velocity. Say this is the door that is open. Right, door knob is here. The air must be coming out across the whole face of the door at a velocity of 1 meter per second. Okay, this is the most critical, and smoke will spread outwards, right? So the second most critical is the one above the fire floor. So this one will also be open. People will be running away. You need to provide also 1 meter per second. And then where do they run? They run. They go to the ground floor, right? So at the ground floor, assume that the main discharge door is called the main discharge door, will be open to allow air to come out, also 1 meter per second. So in a fire, besides providing 50 Pascal, you also need to make sure the fan is big enough to provide 1 meter per second air velocity through 3 doors. Fire floor door, the door above the fire floor, and the main discharge door. Doesn't mean only these 3 doors are used. No, okay. This door, people will also be running away. This door, okay. What is it trying to say is that if you have a fan that is going to have more than 3 doors open, the fan will be very big. So for the purpose of sizing the fan, it can be very huge. Okay, so they consider 3 doors open. Okay, the door on the fire floor, the floor above the fire floor, and the main discharge door. Is that okay? All right, 3 doors, 2 on successive story, and the main discharge door. All right, to keep the size reasonable. Okay, so this door here, the plan view, is the one here. The main discharge door is the one here. All right, there is 9. So let's go back to the text. Okay, so there must be a 50 Pascal pressure difference. Okay, to prevent smoke from coming in. Then the force is 110. All these figures, like I say, must remember one. And then the velocity also must remember. 1 meter per second through 2 doors, successive story, and the main discharge door. All right. Then we have the relief damper, all right, is to prevent what? Overpressurization. So it will automatically open on its own, air will be let out to keep the pressure at 50 Pascal. Okay. You see, they also use pressure differential sensor, but in fact, the civil defense they came to tell us that they don't quite like this for some reason. Okay, but I also prefer the humble one because you never know, this pressure differential, and when you need it at the crucial moment, they may fail. Okay, they may fail. So the humble automatic damper works fine. Okay, works fine. And here, of course, we have variable speed and so on. So a bit of complexity there. A bit of complexity. Now, okay, this one is single stage operation. This is the first generation. First generation. First generation long, long ago lah, huh? They only have a single fan there. Okay. So once there is a fire, the fan will work. Okay. Is this good or bad? Not so good. Why? Because this fan is not operating normally. Okay. So if you're not operating and then when there's a fire, I call you to work, it may not work. Okay. So that is a drawback. All right. The single stage, it may not work. Secondly, if you have been to certain staircases, especially those basement, the staircase can be, the air can be so stagnant. You go in, very suffocating. You feel like dying. Okay, literally true. So the first generation give way to the second generation. So the second generation is a two stage, meaning we have a fan there, but this fan is running at low speed. Low speed. Fire or no fire is running. No, sorry. No fire is running at low speed. This is to provide two good things, right? Provide ventilation to the staircase. Also, let's say if I have a fire, the initial fire, baby fire, there will be smoke produced, right? All right. The fan is already working. So the initial smoke will be prevented from coming in. Here, this one, no, you must, the smoke may come in, the incipient fire smoke may have come in already. Here, because it's already running at a low speed, smoke will be prevented from coming in. Okay? Once the signal has been given to this fan, then it will go to a high speed. All right, that's why it's called a two-stage. Okay, once it goes to a high speed, it will certainly prevent the smoke from coming in. Okay, so this is improvement, right? It provides ventilation, and then it can prevent initial smoke from coming in. All right. This one I explained already, huh? Okay, the containment and exhaust method. Okay, downstand and all those. Okay. And then the clear layer height 2.5 meters. Okay, this is the one so-called advocated by the civil defense, and the three criteria: radiant heat, visibility, and carbon monoxide level. Okay, we must take care of that. And like I said, the smoke is being exhausted, so air must come in to replace the smoke, and it must be at low level. Why? Because when it's at low level, it gets heated up, then it goes up. Let's say if you have a atrium building and the fire, the smoke, then you have the smoke, air coming in at high level. All right, air at high level. This one is very cold. So when it's cold, it mixes with the hot gases. The whole thing will drop down. Okay, there's not enough buoyancy. So it's better for the air to come in, the cold air to come in at the bottom. Then it gets heated up by the fire. Then it goes up. Okay. We all know all the smoke fans must be powered by secondary power. Okay. The building genset. Right. So then here it talks about smoke curtains. Okay. So smoke curtains can normally at the perimeter of the atrium, can also be on the sideway, okay? Prevent smoke traveling in the latitudinal direction, all right? But of course, you must have staircase for people to run away, all right? To create a smoke reservoir, I explained about this on this already. So these are the smoke curtains. By the way, there's a difference between smoke curtains and fire shutters. Fire shutters prevent fire from going from one place to another. Okay. So here I have talked about pressurization system. The smoke containment as well is engineered smoke control system in the atrium lah. So now we also have smoke purging. All right, means to remove the smoke. It looks something like this, and you may wonder what's smoke purging. Okay, so smoke purging means air coming in here. Okay, then here we remove the smoke. Okay, 9 air change per hour. All right, 9 air change per hour, and normally use on car parks. Okay, car parks, and you must have a remote manual start stop switch in the FCC. All right. The fan must be able to withstand 250 degrees C for 2 I don't think you need to remember this. Okay, so smoke spurging. Then for basement, you also need to have separate basement must have their separate smoke fan. This one is natural vents, okay? Natural vents. And they must be spaced out appropriately, all right? This is a ductless jet fan, okay? Ductless jet fan is not simply installed in any fashion. No. You must have your supplier or vendor. It must work with another set of fan, right, to remove the smoke. So this is also an engineered smoke removal system. And the civil defense does, of course, it has been around for quite some time already. They allow this kind of ductless jet fan. I don't know how much time I have left. If you don't mind, can I show you a video on this? Or if you have, okay, maybe I talk about this now. So where do you put your smoke control system? Staircase, internal staircase, smoke lobby, fire lift lobby, okay, rooms, pump rooms. These are rooms that are important for the fire safety manager, right? Fire command center, okay. Rooms that have flammable liquids and explosive substances, basement, internal corridors, warehouses, okay, kitchen. So maybe the jet fan, okay, you can watch later. Redundancy means you must have extra fan in case one break down, the other can take over lah. That's the meaning lah, huh? All right. It may sound foreign to some, right? But it means that you must have a backup in case one is under routine maintenance or breakdown, then the other can take over. Okay. Okay, so this one is the code for redundancy clause on 7.5. A standby fan must be provided, okay, for each of the following system. Okay, very good. Okay, okay. I hope you have some time. Let me see how long is it. Okay, this is a ductless uh, jet fan. 1 minute when you can. I must work in conjunction with another set of fans, okay? So there's a fire here, so the jack fan will blow. In a certain direction, okay, towards the other set of fans, all right, that will bring it up. Okay, so the civil defense, they don't just simply accept your idea, no, you must do some simulation, computer simulation, right? See where the okay, so it's not simply accepting your ideas. So when you see the word CFD, it means computer. CFD stands for, you can say it's a computer kind of simulation that you need to use some kind of software to simulate the smoke flow, and you must show it to the civil defense, and if found acceptable, then they can approve your design. This is called performance-based, okay? Performance-based. Okay, CFD stands for computational fluids dynamics, okay? These are computer software now. So all these are under performance-based, right? Performance-based. And each one has their own merit separately. Okay, great. So now, do you have any questions on smoke control?
So can go back to just now one slide about what clause 7.5. What is that?
Redundancy. Redundancy means that you must have extra. Okay, extra in case your fans under maintenance, breakdown, the extra still can be used to provide the necessary flow rate. Okay, in case there is routine maintenance or breakdown, okay, the system is not entirely crippled. So the word redundancy, these are all taken from the code of practice. For example, in your car park, if you have two fans, the other day I went to the car park, I saw three fans instead of two, right? So the third one would be a redundancy, okay, redundancy. But it's still able to provide half the capacity, right? So if you have three, all right, A, B, C, so each one have their provide the same capacity. So at any time, two will be running, right? BC or AB or AC. So if one is not in operation, Chong out or under maintenance, the other two still can operate. That's the meaning. It's a very general term. Right? All right, so we have talked about smoke control, two methods. One is the smoke containment and exhaust. This is a real exhaust of smoke. The other is not exhausting smoke. The other is to prevent smoke from coming into the safe areas, okay, where people escape. All right. Got the idea? Okay, great. So now, if you're all right, I'll turn off the recording.
Chong,
Hi.
Eunice, no? I think it's okay
Ah.
to leave the recording on. It's okay.
Okay.
Yeah, it's okay.
Okay, thank you.
Are you done already? Because it's quite late. Yeah.
Yeah, almost. These two topics very heavy. Okay, I'll take a few minutes and you'll be on. Okay, of course, smoke control is a very important topic, huh? Not just for tests or exam, but it's practically important topic in terms of saving lives. Okay, lives are involved. So, let's go to the crux of the matter. Okay. Okay, sorry, I got the wrong book. So, of course, just now I told us, we must be very, must have this number at your fingertips, all right? The 50 Pascal is to prevent smoke from coming into the safe areas, okay? And the force at the doorknob should not be more than how many newtons?
110. Sir, are you muted? There's no sound.
You are muted.
Since when I was muted, beginning. So I was saying that when the exit staircase is greater than 4 stories, we need to have a smoke-free lobby. This, I think, is not inside the notes. Okay, so when the door is open, people running away, what is the velocity of the air? How many meters? Okay.
1 minute.
Right?
1 meter
Oh, my
No,
1
per
minute.
second.
meter per second. 1 meter per second. There will be 3 doors open, like 2 on successive story and 1 at the main discharge. Okay. Okay, why is smoke considered as potentially lethal? Lethal means can cause death. Why is it considered as lethal? Okay, to give you a hint, what's the main killer in smoke?
Carbon monoxide. You remove the blood, then don't know what. Then the blood, then the
Yeah.
body, no air.
It has a strong affinity for hemoglobin to form carboxyhemoglobin. So, let's say this one is the staircase, staircase, and this one is the lift lobby, and this one is the corridor. Okay. So if this is so complicated, the difference here should be 50 Pascal. All right. There's a fire here. We want to prevent the fire from coming into the lobby. You must have 50 Pascal. This is a plan view now. However, if this is 50 Pascal, then the staircase fan here should be greater than 50, understand? Okay, this one, you need some kind of calculations to help you understand. Okay, so this one will be greater than 50. Okay, so I just let you know lah. But if you want to go deeper, it involves some calculations. So the main function of smoke control system in an atrium of a shopping mall. What is the main function of smoke control system? Let's say in the atrium mall, shopping mall.
To let the smoke to remain at the top, so it form like a blanket, so the smoke won't come down and smoke the face, the human.
We form a reservoir, and of course, we want to prevent the smoke from getting into the occupied areas. So there's curtains and all those things. And then we form a reservoir, and the smoke fans can easily exhaust the smoke. Okay, so it prevents smoke spread to the occupied areas, and also allow the smoke fans to exhaust the smoke easily. All right, easily. That's about all. Okay, that's about all. Okay, are there any questions? Sorry for taking so long, almost half an hour. But this is a heavy topic. Are there any questions of any kind?
I think Ching, we need to close the session. It's overrun. Yeah, so we need the participant to rest. Can you turn on your camera? You take a class picture.